This is a very tough little geometry problem from the intermediate maths challenge. We've got a circle inscribed in a semicircle with centre O and diameter AB. The centre of the circle is at the point P, and PA equals PO. We want to know the ratio of the radius of the circle to the radius of the semicircle. Let's call the radius of the semicircle, the larger circle if it were a full circle, capital R, and the radius of the smaller circle, small r. And we'll try to write some things down in terms of those values. In particular, I'm going to draw a triangle here with a line from P to O and a perpendicular line from AO to P. Now the length PO is going to be capital R minus small r, the radius of the larger circle, minus the radius of the smaller circle, as you can see here. If you're worried about that at all, notice that there's a common tangent at the point where the circle intersects the semicircle at the top there, and so both of the radii from that point to P and from that point to O will be perpendicular to that tangent, and so we really do get a straight line here, and we can write that PO is capital R minus small r. Clearly we've got this vertical line is the radius of the smaller circle, which is small r, and then the base of the triangle here is going to be capital R divided by 2, because AO is a tangent to the small circle, so we've got a right angle triangle here, and we know that PA is equal to PO, so I could draw another triangle like I have just to the left of it, with PA also equal to capital R minus R, and we can see they would be two congruent triangles, so this point really must be halfway along AO. But this is a right angle triangle, and we can apply Pythagoras theorem to it. So we've got small r squared plus capital R over 2 squared equals capital R minus small r all squared. Multiplying out, we've got small r squared plus capital R squared over 4 equals capital R squared plus small r squared minus 2 times capital R times small r. We've got fractions here, so if we multiply through by 4, we would get this line, and we can see we've got a 4 small r squared on each side that we can subtract, and doing a little rearrangement gives us 8 times capital R times small r equals 3 times capital R squared. We know that the radius of each of these circles isn't going to be 0, that wouldn't make sense in this problem, so I can divide through by capital R and get 8 times the small radius equals 3 times the large radius, so that finally gives us a ratio of 3 to 8, and the answer here is B.